Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video we'll discuss some problems based on multi-stage amplifiers which we have studied in the previous few videos. Okay, so you have to see how I approach the problem and how I draw the AC equivalent model. Because if you understand how to draw the AC equivalent model, you can solve any problem. You don't have to memorize any expression. So let us start with the first problem on the screen. If you see, it says for the circuit given, find the voltage gain. Okay, it is asking us this. Now this is not a multi-stage amplifier, but this is a single stage amplifier. Since no values are given, I'll derive an expression for the voltage gain. Now it says neglect the effect of early voltage. Whenever it says this, understand that R0 tends to infinity or R0 will be open. In such a case, I can use two models, either the T model of BJT or I can use hybrid pi model. Let me approach this problem by the second option, that is hybrid pi model. For AC model, what steps do you have to take? For AC model, we short circuit capacitors. Okay, that is I am talking about mid-band gain. And also we ground the DC supply or VCC. So we will ground this. Now once you ground it, what happens is, if you see, this R1 and R2 will come in parallel. Okay. So now let me try and draw the model. I'll draw on the next slide. See. First there is V in. Okay. This is V in. It is connected to the base of BJT. If capacitor is short, this V in is connected to the base of BJT. Then between base and ground, this R1 and R2 are connected in parallel. Between base and ground, R1 and R2 are connected in parallel. When we talk about hybrid pi model, I draw a resistance R pi which has a voltage V pi between base and ammeter terminal. Okay. Now see, this ammeter terminal is bypassed by a capacitor C3. So if C3 is short circuited, the ammeter gets connected to ground. So this ammeter will be connected to ground. Then between collector and ammeter we have a current source which is GM pi. This terminal is collector. Okay. In GM pi we have a parallel resistance R0, but it is saying neglect early effect, so R0 will be open. Then see this RC. RC is connected between collector and ground. So between collector and ground I will connect RC. Okay. After that, if you see, this capacitor will be shorted, and between collector and ground we have another resistance RL. So between collector and ground we have another resistance RL. Always remember, just define one ground in the circuit, not multiple grounds. From this circuit, if you see that this voltage V pi is connected in parallel to V in, so what I can say, V pi is actually equal to V in. And these two resistances are in parallel, so what you can do is, you can remove this resistance and write here RL parallel RC. This is V0. Now this GM V pi current will go like this. So plus minus will be like this. But V0 polarity is opposite. So what I can say, V0 is minus current multiplied by resistance. So when you take the voltage gain, V0 by Vn, V pi will get cancelled. So it will be minus GM RL parallel RC. Okay. This was an example on the single stage amplifier, so that to revisit how we used to solve for single stage. Same sort of methods I'll apply next problem to the multi-stage amplifier. Moving on to the next problem, it says for NPN transistor beta equal to 100, we need to find voltage gain if thermal voltage is 25 millivolt. Now here all the values are given, so we first need to perform DC analysis to find amplifier parameter. So first I will perform DC analysis. In DC analysis what I will do is capacitor will be open circuited and AC source will be grounded. If you do that, then this terminal, base terminal, will be connected to ground. Now let us see how we can solve such a problem. This voltage becomes 0 because I have grounded AC terminal. The VBE will be 0.7, so this voltage will be minus 0.7. So what is the current here? Let me call it as IE1. This is transistor Q1, Q2. Now when you write IE1, you will write minus 0.7 minus. The voltage at the other terminal is minus 10 over 9.3K. So it is 1 milliampere. Now beta is high, so what I can say, beta is 100. So what I can find out is the collector current. This will be IC1. Okay, this will be IC1. If you say, if beta is high, I am just making an approximation that I am ignoring base current. So what you can say, IC1 equal to IE1 equal to 1 milliampere. If you ignore this base current also, this current will also be 1 milliampere. So you can find this voltage, the collector voltage of Q1. The collector voltage of Q1 can be found out using KVL. 10 minus 9.3K into 1 milliampere, that is 0.7 volt. If it is 0.7 volt, what you can do is, this drop will also be 0.7. This voltage is 0.7. So what is the voltage here? It will be 0. 0.7 minus 0.7 will be 0. That means I can find out IE2. For finding IE2, what I will do, 0 is the voltage at the upper terminal, minus 10 at the lower, by 5K, that is 2 milliampere. So I have found out the currents in both the transistor. If I know the current in both the transistors, I can find the parameters of both transistors. I know that IE1 is 1 milliampere and IE2 is 2 milliampere. So based on this, I can find out the parameters of hybrid pi model. For hybrid pi model, the first parameter is R pi, or you can say GM. First we will find GM. GM1, how do you find out? GM is ICQ by VT. For first transistor, collector and ammeter current is 1 milliampere and VT is 25 millivolt. So it will be 0.04 ampere per volt. What about R pi 1? It will be beta over GM1, 100 by 0.04, that is 2.5 kilo. What about GM2? GM2 will be 2 milliampere by 25 millivolt because the current has changed, 0.08 ampere per volt. What about R pi 2? It will be 100 by 0.08, or you can say 1.25 kilo. So we have found out the amplifier parameter for both the transistors, but why we needed to find it out? Because we want to draw the amplifier model. Now let me clean this up, all the currents and voltages that I have marked for AC analysis. Okay. So for AC analysis, what I'll do is, I'll ground the DC supply. I will short circuit these capacitors. If you short circuit this capacitors, 9.3K and 5 kilo ohm will get grounded. So let me start with the first transistor. Okay, don't worry about it, just go transistor by transistor. The base of first transistor is connected to V in. Okay, is it fine? We have reached the base. Between base and emitter, we will have a resistance R pi. This is R pi. This voltage is suppose V pi 1. This is R pi 1. Now this is emitter. The emitter is grounded due to this bypass capacitor. So this emitter is connected to ground. Then between collector and emitter we will have a current source, and see this 9.3 kilo ohm resistor. It is connected between collector and ground. So between collector and emitter we will have a current source GM1 V pi 1. This is your collector terminal. Between collector and ground we will have a resistance 9.3K. Okay, we will not show any R0, because for R0 we need early voltage. If early voltage is not given, I will assume that early voltage is infinite. Now this collector terminal is connected to base of the second transistor. So this is base of second transistor. Between base and emitter I will again have a resistance R pi 2, whose voltage will be V pi 2. So we have reached the emitter. Now this emitter is grounded due to this bypass capacitor. So emitter is connected to ground. Then between collector and emitter we will have a current source GM2 V pi 2. This is your collector terminal. Now see this 2 kilo ohm resistor is connected between collector and ground. 2 kilo ohm resistor is connected between collector and ground, and collector is connected to V0. So what we need is the voltage gain. Is it fine? So how will you find the voltage gain? Let me try and solve this network. If you see this V in and V pi 1 is equal. Now this current is GM1 V pi 1, and these two resistances are in parallel. So what you can do is, you can find out R equivalent is 9.3 kilo ohm in parallel with R pi 2. If you know R equivalent, how you can find V pi? See, this current is going like this. So plus minus will be opposite. So you can say V pi 2 is opposite polarity minus GM V pi 1 into R equivalent. Now you know V pi 2. So this is V0, and this current is going like this, plus minus. So how you will write V0? V0 is minus GM2 minus GM2 V pi 2 into 2 kilo ohm. Okay. So V pi 2 is minus GM2, V pi 2 is minus GM1 V pi 1 R equivalent. Okay. So V pi 1 is V in. So V0 by V in is GM1 GM2 R equivalent into 2 kilo ohm. GM1 was 0.04, GM2 was 0.08, R equivalent is 9.3 into R pi 2 was how much? 1.25. 9.3 plus 1.25. Okay, this is actually plus. I am taking parallel into 2 kilo ohm. But remember, both these quantities are in kilo ohm. So kilo into kilo is 10 to the power 6. Okay. So this gain comes out to be 7052.13. So this gain is very high because here we have cascaded two common emitter amplifier, or you can say it is a cascade connection, and always cascade connection has a very high voltage gain. Okay. So what I have done is I have analyzed it stage by stage. First I have drawn AC equivalent of the first stage and then AC equivalent of the second stage. Moving on to the next question. It says calculate all the node voltages and the branch currents if beta equal to 10 and VBE equal to 0.7. Okay. We want to find out the node voltages and the branch current. That means it is not asking about the AC analysis, it is only asking about DC analysis. So if you see this is a voltage divider biasing. If this is a voltage divider biasing, what I'll do is I'll find the Thevenin. So in order to find the Thevenin, what we'll do is, this is 100 ohm. This one is again 100 ohm. Okay. This is 10 volt. This will be your VTH. So what will be VTH? 10 into 100 by 100 plus 100. That is 5 volt. What about RTH? It will be 100 in parallel with 100. That is 50 ohm. So if you draw this network again, what we'll do is 5 volt in series with 50 ohm. This will be 10 ohm. The collectors are connected together and this is 10 volt. Okay. So this is 0.5. This is 0.7. This is also 0.7. So now if you see, if I show the currents here, suppose this current is IB1. Ammeter current is how much? Ammeter current is 1 plus beta. 1 plus beta is 11. So 11 IB1. What about ammeter current? Again 1 plus beta, which means 121 IB1. Now apply this KVL. So I'll write 5 minus 50 IB1 minus 0.7 minus 0.7 minus 121 IB1 into 10. So that means IB1 will be 5 minus 1.4 is 3.6 and 1260, and that is in ohms. So 3.6 divided by 1260 will be how much? It will be 2.857 milliampere. So we have calculated the base current. Now if you know the base current, you know all the branch currents. First one is IB1, 11 IB1 and 121 IB1. So what is the node voltage here? VE2 will be 121 IB1 into 10. So it means IB1 into 1210. So that is 3.457 volt. Okay, that is the node voltage. What about this node voltage? You will add 0.7. 3.457 plus 0.7. This will be 4.157. This is 4.157. And we know each and every node voltage. This node voltage will be 10 volt. This will also be 10 volt. So that way we have calculated all the node voltages and all the branch current. So this question is simply based on DC analysis and not the AC analysis, but it is making use of Darlington pair. Okay, moving on. Next question. It asks us, given the transconductance of transistor Q1 is GM1 and for Q2 it is GM2. We need to find the overall transconductance. Now here it has also given us the expression of overall transconductance GM. It is del I naught by del V in. If you see this figure, what is I naught? I naught is nothing but IC1 plus IC2. So you can say the overall GM is del IC1 plus del IC2 by del V in. Now by KVL, what you can say is V in is VBE1 plus VBE2. If both VBE are equal, you can say it is 2 times VBE. So this can be written as del IC1 del IC2 by 2 times del VBE. So it is half del IC1 by del VBE plus del IC2 by del VBE. So this first factor is the transconductance of the first transistor. Why? Because output current of first transistor is IC1 and input voltage is VBE1. Output current of second is IC2 and input voltage is VBE2. So half GM1 plus GM2. So that is the overall transconductance, that is the average of transconductance of each stage. Okay, that will be the overall transconductance of your BJT. Is it fine? Moving on to the next problem, it says in the cascade amplifier circuit shown in the figure, we need to find the values of R1, R2 and RL such that quiescent current through transistor is 1 milliampere. Collector voltages are given. VBE is 0.7 and beta is assumed to be high to neglect base current. Okay, it is a lot of information to take in. So we'll go one by one. We know that a quiescent current is 1 milliampere. Collector voltages are also given. This voltage is 3 volt. This voltage is 6 volt. Base current is neglected. 0 ampere. 0 ampere. Now VB is 0.7, 0.7, 0.7. Okay, and it is saying that the quiescent current is 1 milliampere. If the base current is 0, the collector and ammeter currents are always equal. Okay, so this information is given to us. We need to find the value of R1, R2 and RL. So how will I start? I'll first find this voltage. VE1. VE1 is how much? 1 milliampere into 0.2 kilo ohm. 200 ohm is 0.2 kilo ohm. So it is 0.2 volt. Now this drop is 0.7. So what is VB1? VB1 is 0.2 plus 0.7, 0.9 volt. I know this much. Now, first I will find out RL. How you will find RL? The upper terminal voltage is 9, the lower terminal voltage is 6, and the current between them is 1 milliampere. So this is 3 kilo ohm. So RL will come out to be 3 kilo ohm. First resistance is clear to me. Now this is 3 volt and this voltage drop is 0.7. So this voltage will be 3.7. When we are doing DC analysis, this capacitor will be open. So don't short circuit it, but it will be open circuited. Now we need to find the value of R1 and R2. We know that VB1 is 0.9. So can I find this current I? I is 0.9 by 18, 0.05 milliampere. Now since there is no current going into the base, this current will also be I. This current will also be I. Based on this, I can write R2 as the upper terminal voltage is 3.7. Lower terminal voltage yani VB1 is 0.9 by I is 0.05 milliampere. 2.8 by 0.05 is 28 by 0.5, 56 kilo ohm. Same you can do with R1. R1, the upper terminal voltage is 9, the lower terminal voltage is 3.7 by 0.05. 5.3 by 0.05 is 53 by 0.5, 106 kilo ohm. Okay, so we have found out the value of R1, R2 and RL. Out of this, RL is very simple, you can find it directly, but for R1 and R2 you have to take care that there is no current going into the base. Moving on. The question says the figure shows a two-stage amplifier. Let us read the question carefully. The transistors Q1 and Q2 are identical. Okay. Beta is 100. And the DC and the AC current gain both are equal to beta. The Zener diode has a breakdown voltage of 10.7. Assume that the Zener diode is in breakdown region. So when it says Zener diode is in breakdown region, I will mark the voltage here as 10.7. And dynamic resistance RZ is 0. If it says dynamic resistance is 0, it means this Zener diode will be simply replaced by a voltage source. There will be no Zener resistance. The capacitor C1 and C2 are large and provide negligible impedance at signal frequency. This statement means when you will apply AC signal, the capacitor C1 and C2 will be shorted. Okay, that means first identify the configuration of each stage, quiescent quantities IC1 and VC1 and the voltage gain. So first of all, let us understand what is the configuration. See Q1. In Q1, the input is applied at the base terminal and output is taken at the collector. If input is at base and output is at collector, this is common emitter. Now this output of first stage is acting as the input of the second. So input is connected at emitter and output is connected at collector. If input is at emitter and output is at collector, this is common base. So first transistor is common emitter, second one is common base, which means it is cascade connection. Okay. So this is a complete question based on cascade connection. How will I tackle it? I will first draw the DC analysis, or I will first find the DC analysis and then I will go for AC analysis. So for DC analysis, what I will do is, I am removing whatever I have written. For DC analysis, this voltage is 10.7. I will open circuit the capacitors in DC. Now this voltage is minus 10 and then there is a voltage addition of 10.7. So the voltage here is 0.7. Then VB is also 0.7. This voltage drop, which means this VC1 will be 0 volt. VC1 is 0. Okay. Now this VEE is minus 10. This drop here is 0.7. So the voltage here is minus 9.3 volt. Okay. The voltage here will be minus 9.3. So what about this current? This current here, suppose I is minus 9.3 over 930. That is how much? 0.1 ampere. Sorry, 0.01 ampere, or you can say minus 10 milliampere. Okay, that is the current. So what other things we need to find out? We have find out VC1. We also need to find out IC1. Now how you will find out IC1? This capacitor is open. We have found out this I. So this I current will be here as well. If this is the I current, so I current is opposite to the direction. If I current is opposite to the direction, what does that mean? That means the base current should be like this. The base current should be going into the transistor. This is your base current. So base current will be minus I, or you can say 10 milliampere. So what about the collector current IC1? The collector current IC1 is beta into IB. If it is beta into IB, beta is how much? Beta is 100. 100 into 10 milliampere, it is 1 ampere. Okay. So that means the collector current for the first transistor is 1 ampere. Is it fine? So the second part is also solved. It was asking us to find IC1 and VC1. Is it fine? So what I have done is I have calculated the base voltage of Q1. Based on that, I have found out the current in RB, by which I have found out the base current in Q1. Using base current in Q1, I have found out collector current in Q1. Now in order to go for amplifier, what do I need? For going into amplifier, I need to find out the transconductance. The transconductance is IC by VT. VT is given as 25 millivolt. 1 ampere by 0.025 is 40. Okay. So that will be 40 ampere per volt. Is it fine? What about R pi? R pi is given as, for the first transistor, is beta by Gm. So that is 100 by 40, or you can say it will be 2.5 ohm. Is it fine? This R pi is something which is equal to beta Re. So Re will be 25 milliohm. So we have evaluated the transistor AC parameters, transconductance and R pi. We can assume that for the second transistor also we will have the same parameters if we ignore the base current. Because if you ignore the base current, the currents in both the transistor will be same. If current in both the transistors are same, then their AC parameters will also be same. See, transconductance always depends on the collector current. If you ignore the base current, the collector current of both the transistors will be equal, and if collector current of both the transistors is equal, their transconductance will also be equal. Now let me remove all this that I have drawn on the figure. What I will do now is I will try and draw the AC model. So when we talk about AC model, what I will do is I will short circuit capacitors and also I will ground DC supply. Okay. Now Zener diode also acts as DC voltage source. So it will also be shorted. Okay. So now when you draw the AC model, let us go step by step. Vs is connected to base of Q1. So first I will draw Vs. It is connected to base of Q1. Now between base and ground you can see there is a resistance of 930 ohm. Between base and ground there is a resistance of 930 ohm. Between base and emitter we have a resistance R pi. This voltage is suppose V pi 1. Now this is your emitter terminal. If you ground the DC supply, this emitter is connected to ground. So this emitter is connected to ground. Then between collector and emitter I have a current source GM1 V pi 1. So this is my collector terminal. Now this collector terminal is connected to base of the emitter of the second transistor. And if you show the resistance in emitter circuit, it is always Re. Okay, it is never R pi, it is always Re. And this will be the ammeter terminal of second one, and this will be the base of second. Between ammeter and base we have a resistance Re. Now this base will be grounded because DZ will be shorted and this supply will be grounded. So this base terminal will be grounded. Between collector and base we will have a current source like this. This will be beta, or you can say not beta. This will be alpha IE2. This is IE2. Okay, this is alpha IE2. This is your collector terminal of second. We are ignoring the early effect. R0 is infinite. Then between collector of the second and ground, VCC is grounded. There is a 4 kilo ohm resistor. Collector of second and ground, there is a 4 kilo ohm resistor. Then between collector and ground there is another 4 kilo ohm resistor because this capacitor is shorted. So this capacitor is shorted. There is another 4 kilo ohm resistor. This is RL and this is V0. So now we need to find the voltage gain. So first of all, the first thing to be observed, by KVL I can say V pi 1 is equal to Vs. Okay. And if you apply KCL here, you can say that IE2 is GM1 V pi 1, or you can say GM1 Vs. Now these two resistances are in parallel. 4 kilo ohm and 4 kilo ohm in parallel means how much? It means a overall resistance of 2 kilo ohm. This is V0. But this alpha IE2 is flowing like this. So the polarity will be opposite. So what you can say is V0 is minus alpha IE2 into 2 kilo ohm. Now this IE2, we just now wrote this IE2 is GM1 into Vs. GM1 Vs into 2 kilo ohm. That means V0 by Vs, which is the voltage gain, is minus alpha. Alpha is beta over 1 plus beta. GM1. We derived GM1 as equal to 40. 2 kilo ohm is 2000. So minus 100 over 101 into 80,000. This factor is almost 1. So it is almost minus 80,000. That is, this is a cascode amplifier with a high voltage gain of minus 80,000. Okay, what is the benefit of cascode connection? It has high gain as well as large bandwidth. Next problem, it says in the circuit shown, transistors Q1 and Q2 are biased at a collector current of 2.6 milliampere. Assuming that the transistor current gains are sufficiently large to assume collector current equal to ammeter current. Gains are sufficiently large to assume collector current equal to ammeter current. It means that base current is 0. Thermal voltage is 26 millivolt. We need to find the mid-band voltage gain. Now in transistor AC analysis we have two options. Either to use the T model or to use hybrid pi. The only difference here is the current source is beta IB. Here the current source is GM V pi. Now if you see, based on the question, it is saying IB is 0. If IB is 0, you cannot show this current source beta IB. So it is necessary for us to go for hybrid pi model. Always remember, we cannot always use beta IB model if IB is 0. Or you can say the input resistance is infinite, the T model cannot be used. We have to make use of hybrid pi. Now let us see how we will draw the AC model for this. Okay, for that we need transconductance. Transconductance is nothing but IC by VT. This collector current is 2.6 milliampere. The voltage is 26 millivolt. 2.6 by 26.1 ampere per volt. Now see this. This is a NPN transistor. This is a PNP transistor. We know in NPN and PNP transistor the current directions are opposite. So what you can do is you can reverse the current direction and the voltage polarity. But because we are dealing with AC analysis, it is your choice. You can also keep the same direction. Are you getting my point? AC is positive in half cycle, then negative in other half cycle. That means after every half cycle, the current direction will be reversed. So the current sources that you are showing in NPN and PNP, you can show in the same direction or in opposite direction. It is your choice, because anyways in AC analysis after every half cycle the current will reverse. Okay, that is why I told you when we talk about PNP transistor, the AC model remains same, because in AC current anyways reverses. So don't get afraid of this. Let me start it one by one. First I'll draw VS. Okay, this is VS. It is connected to base of the first transistor, but since base current is 0, R pi will be infinite, or you can say there will be no current. That is why I am showing here open circuit V pi. Now this is your ammeter terminal. Between collector and ammeter we have a voltage source GM V pi 1. Suppose this is V pi 1. Now this is collector. See this collector is connected to V0. This is V0. If you ground the DC source, then this 1 kilo ohm is connected between collector and ground. So this is your 1 kilo ohm. Now that is the model of first transistor. C. This ammeter is connected to another ammeter. This is connected to another ammeter. Between ammeter and base you will show open circuit. Okay, but now instead of ammeter base voltage, or you can say instead of VBE, or let me write like this to make it clear. This is VBE1, VBE1. So in PNP transistor, instead of VBE we have a voltage source VEB. Okay, and this is the base. Now base will be grounded due to this capacitor. The base will be grounded. Okay, and between ammeter and collector, we will have a current source. The current will go from ammeter to collector because it is PNP. Are you getting my point? In NPN the current goes from collector to ammeter. In PNP it will go from ammeter to collector. So it is GM VEB2. Is it fine? Now this collector terminal is also connected to ground. See, this collector terminal is also connected to ground because this minus 5 volt will be grounded. Again I am repeating, I have drawn the AC model of NPN transistor very normally. Okay, I have drawn it very normally. But if you see, ammeter of Q1 is connected to ammeter of Q2. So this is ammeter 1, this is ammeter 2. In PNP transistor, we have voltage from ammeter to base. So this voltage I have shown as VEB2. And base gets connected to ground due to short circuit capacitor. In NPN, the current goes from collector to ammeter. In PNP, the same current goes from ammeter to collector. So this is GM into VEB2. And this collector is also grounded. So this collector is also grounded. Now if you apply KCL, you can see that this current is flowing like this. So in a single branch, only one current can flow. So that means these two currents should be same. So you can say VBE1 is equal to VEB2. Now apply this KVL like this. Vs will be equal to VBE1 plus VEB2. And since both are equal, 2 times VBE1. So that means VBE1 will be Vs over 2. Now what about the output? This current is going like this. V0 will be like this, but due to current the polarity is opposite. So what is V0? V0 is negative sign Gm VBE1 into 1 kilo ohm. Now this VBE1 is nothing but Vs over 2 into 1000. So V0 by Vs, which is the voltage gain, transconductance was how much? We just now wrote that the transconductance was 0.1 by 2 into 1000. So 500 into 0.1 is minus 50. So the voltage gain of this transistor will be minus 50. So for such kind of problem, even if you have memorized many formulae, you can't solve such questions. And that is why I am again and again telling you, try and understand how to draw the model of BJT, and then you need not worry how difficult is the question. You can always find the answer using basic network analysis. Okay. So this will be all from this video, and we'll continue in the next lecture. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase, and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me, and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes, and share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.